Good evening.
Good evening, sir.
Good evening. Am I clearly audible today?
Yes, sir.
Okay. All right. So should we wait for a few more or we start? Only 11 people, 10 people have joined. Today, uh, let's do one thing. It is not going to be as intense as the last class was, right? Because we had to cover many of the basics in the last class. That is why we had to spend most of the time on just the theory part, right? Only the explanation. So today I will keep it light and maybe we will conclude early too. Okay. Uh, we will just do whatever we did in the theory part. We will just do that in the collab. Okay. The coding part we will do. Later on, if you have any doubts regarding the last classes concepts that I had explained, if you have anything like that, we can discuss that also. Okay. Tested something once again. By the way, from today onwards, you will have to join the course using the same email ID that you have used for enrollment, because it is going to be exclusive for only those who are um, enrolled to the class, right? So you must have gotten the invite through your email address, I guess. So follow that or create your profile in Teams using the same email address. Then if you try to join, you will not have to wait in the lobby. Otherwise, you will appear as a guest in the meeting and I will have to let you in to um, for you to attend the class. Okay. Today I will allow whoever tries to do that. But from tomorrow onwards, you will have to use the same email address. Okay. Right. Shall we start then? If you are there. Anyway, but we can't wait for everyone, right? That is not going to happen. So let me share my screen. Okay. I hope it is visible to everyone. Okay. So this was what we had discussed. It is part of the same notebook. I'm keeping it as it is so that I can share it with you if it is necessary for the later references. By the way, if you follow along when I do the coding, if you follow it with me, this will not be that necessary anyway. Okay, that is in. So let's start with the different representations we had already seen, but some operations, right? Uh, five operations, four or five operations we had discussed on the previous class. What were they? Can anybody summarize what were the theory parts that we had discussed? I mean, the operations I had explained in the previous class. Dot product, matrix transpose, cross product. Okay. Apparently, many of you remember that. So let's import NumPy as NP. Okay. Let's take a scalar value. Let me take it as A. One thing I forgot that day to show you is we saw that it is going to be a scalar value, right? And we also saw another that actually looked like this, np dot array for that maybe comma, 3, right? This was a vector, correct? Now there is one attribute that you can actually use to see what is the dimension, how many features or what kind of data it is in NumPy. That is called a dot shape. A can be any object. I mean, whether you are using a vector or a matrix or whatever it is, right? Is it an image or a data frame? Whatever it is, a dot shape will give you the dimensions. A doesn't have anything, 0D. What about B, right? It has four columns, 1, 2, 3, 4, and this is the dimension you have. Okay, if we have uh, something like C, NP dot array, let's define an actual array here, 1, comma 2, comma 3, and then this is one row, right? I hope you guys can follow it along. Maybe 4 comma 5 comma 6 C dot shape. Can you see this? Two rows, three columns. Okay. It is just to understand. I was supposed to tell you that in the first class itself, data representation class, I missed it there, so that is why I'm showing it to you now. Just so that you keep that in mind. Fine. Okay. Now let's come to the arithmetic. Um, shall we take this small example, image array, right? So that you will we can see the scalar multiplication part. This is the array that we have, and then this is the image that this was the code to display the image. Right? We had done that. Let me just print. So this is how it was, right? I hope you remember this. Okay. Now, if I change this array from instead of 255, let me take it as 127. Do you remember what that example that I had taken in the last class? 127. I had mentioned that it is supposed to look somewhat grayish. Is it or not? Ah, 1 second. Just give me a second. There is one more thing that we need to pass here. The maximum value. Just give me a minute. Someone has come, I guess. Yeah, sorry guys. Shall we continue? Yeah, I'm recording. Okay. So now, what was I talking about? Okay, we were trying to display this image with the different intensity, right? We can let's keep it this way, no issues. There is one more thing I think we need to pass to this function. Yeah, interpolation. Yeah, vmin and vmax. Sorry, this is what it is. So vmin is equal to 0 because the values that we are passing, the minimum value for black is 0 and maximum value for white we are supposed to put in 255, right? That is how we defined our array we were thinking about. So when I do this, now you can see it is showing something like this. Can you see the uh, gray area, this part, and then a little darker area over here? Is it visible? Otherwise, I will increase these values a little more. Yes, visible. Fine. So if I, for example, if I change this to, let's say 127 again. Yeah, right. Let's keep this because it is good enough. So now this is the, don't worry about this part. You can simply copy it down. It is only to understand what is happening here. The main part is here, right? This is the data that we have. It is a collection of arrays. This, or we can say it is an image, right? Some data. Now, when I multiply this IMG array with a scalar, let's take it as 2, right? Let's reassign this underscore array is equal to the old array that we had. I am multiplying it with to a scalar value and then assigning it back to the same array, right? Essentially, I'm using the same name. If you are getting confused, we can say old IMG array, right? And this is the new one. Now let's try to see what is happening. Can you see the difference? Previously, if you want, I can display that too. It is anyway there. This is not needed. Problem with this. Both are looking like this, right? Why? Ah, sorry. This was supposed to hold. Yeah. See, this was the old one, which had exact gray colors 127, 127. This was some 10 intensity I had given, whatever. Then we multiplied it with 2 here. We are scaling the same data, and that is when the intensity has increased, right? Hope it makes sense. The same concept we had discussed in the theory part as well, correct? If it is clear, I will move on to the next operation. Has everyone got the output? Write out with me. Okay. So what was the other operation that we had? Let me just check it back. I think I will have to refer back the same notes that I had shared that day. Vector addition. Yeah. So how do you do that? If I have vector 1 is equal to np dot array, pretty simple, right? 2 comma 3. And then vector 2 is equal to np dot array, say 5 comma 7. Then let's print these two. So these two vectors we have, can also take it into a different line, right? So addition, what is it going to look like? VCT 1 plus 2. Pretty simple, right? There is nothing technical about it, right? So if you want to make some intuitive sense about this, we can do something like, hold on. If I say, take another example, let's keep this as it is. Let's move on to a new cell. Take one vector that is position. Let's take it as a position. Okay. Imagine this as you are at the origin point in a Cartesian plane. If you want, I can draw. You just let me know. Okay. Otherwise, I'll explain it in words. Imagine you are uh, at say the origin point 0 point in the Cartesian plane. Now your job is to move from there, change your position from there to, let us say, the Cartesian coordinates 5 comma 7, let us say. Then what is the idea, or how are you going to execute that in any graphical graphics or whatever, right? Whenever you want to execute the same thing, say for example in a a computer game that you are trying to design, there is a character which is at 0 position. Now you want to place it in, say, 5 comma 7 location. 5 is the x coordinate and 7 is the y coordinate. I hope you know how to make sense of it. So how can I do that is the question. And that gives you the application of the vector addition and subtraction. I had mentioned it in the previous class. Uh, let's take the initial position as what, 0 comma 0. Okay. And then if I want to, let us say, move to 5 comma 7, then what is the idea? How do we do that? Uh, we have to move 5 units in the x direction, and then from there we have to move 7 units in the y direction, right? So to do that, what I can do, position wherever it is, right, is equal to position plus np dot array, what, the first place where I want to move, 5 comma 0, right? Now if you display this POS, the current position has changed from 0 0 to 5 comma 0. That means what, we have moved 5 units from the origin and reached the 5 number in the x axis. Now the final, to reach the final position, what do we need to do? We will have to move 7 units upwards or in the direction of y. That is, for that, what can I do? The current position after this modification plus np dot array, what, 0, because I have already moved in the x direction. I don't need to move anymore in the x direction, right? So for that, it is, I am keeping it as 0, but the only distance I need to move is the 7 units in y direction. I'll do that. And finally, I am at which position? 5 comma 7, right? I have taken a very simplistic example in this manner. However, if you are in, say, for example, 2 comma 3 somewhere else, and you want to move into 5 comma 9, right? Then the calculation is going to be a little tricky. I mean, that is how it is in the real world or in real applications. The position or whatever the geometrical location of anything that you are trying to process can be anywhere. From there, say for example, you want to measure the distance, right? Uh, Let me take the whiteboard's help. Because that concept I think is very crucial. Share screen, share my name, chat is done. Okay. Yeah. Are you guys able to see the whiteboard? Okay. Now?
Yes, sir.
Okay. So imagine you are at this position, right? Or say, for example, there is an image that has a lamp post here or something here, a tree here, and then there is another tree drawn in the image somewhere here. Now, if your algorithm, the AI algorithm, or the learning algorithm, if it wants to measure the distance between the two, what is the distance between the two, right? If that is the requirement, then what can I do? What is the logic behind how do you calculate it? One thing is you take this coordinate, you take this coordinate, right? And then you find the distance between the two by what? You simply subtract this vector with this one, right? We can do that if I am trying to uh, find out the distance between the two. Makes sense? Or say, for example, there is something, some object is sitting here, And then from here, we want to move it to this position. How can we do that? You simply add this much distance, the vector, right? Add that to this vector, you will reach this point. Okay. The previous example that I had taken, what? We were at 0, 0 initial position. And then say, for example, I want to move to this point. Then what did I do? I moved in X direction 5 times and then Y direction 7 times, right? Correct. And the resultant position I reached was, how did I do that? From here. So I simply did 0, 0, this vector plus 5, 0 resulted in what? This point, right? 5, 0 I reached. And then from here I added 0, 7. This is another vector, right? This one. So with this, I reach 5, 7. This is the intuition you can draw from vector addition or subtraction. Okay. However, if I am here, if I want to move, say, for example, to this point where y value is, say, 5. This is what I want to reach. Then what can I do? The current position, if it is 5, 7, then 5, 7 minus what? 0, 2, right? Will give you what? Give me what? This also you can do, or simply you can make something like this, minus 2. The same thing. Make sense? So in the y direction, in the y axis, go in the negative direction means what? You come down, right? By 2 units, it will take you to 5, 5, this part, right? So if you have understood and got the output as well, I will go to the next concept, the dot product. Shall I move forward? It's quite simple, isn't it? And share the other screen. That's it. Okay. Now let's do the dot product concept. How to do that? Let's do that first. So if I have uh, say one vector, that is vector, let me take it as v1 is equal to what? Np dot array, right? Let's keep it as say 1 comma 2 comma 3. Anything is fine. I'm just taking any example to show how it is done, the operator and everything. V2 is equal to np dot array 3 comma 4 comma 5. And now, if you want to find out the dot product, there are two ways. One is v1 and then one dot, and then actually the dot function. Inside that you will have to pass the v2. Okay, that will give you 26. It gave actually it gave 26. This is the dot product between v1 and v2. How did it calculate that? 1 into 3, right? Yeah. So 1 into 3 plus 2 into 4 plus 3 into 5. What will be the answer? Screen is not visible, is it? It is. It should be, right. Aren't you able to see the screen? Okay.
Visible,
It must
sir.
be. Okay. So what is going to be the answer here? 3 ones are 3, 3, 4 twos are 8, 8 plus 3, 11. So the 26 answer is correct, right? Yeah. This is one way of doing it. Another way, let me print this, is actually there is an operator that does it very well directly. V1 at V2. Okay. The second answer that we have here, NP, this one, this is actually from this. Okay, this one, the above one, is from v1 dot v2. This dot function stands for dot product, and this at operator, when it is used with the numpy array, does the dot product for you. Okay, now let me take one small example that we had discussed or something that I had shared in the pre-reading material as well. Let's do that similarity concept, right? In the last theory also we did that. Say for example, there is a movie, right? Or there is a user A, who has been profiled like this. The first, the above one, we do that. He has been rated in this manner. Profile contains what? The number of movies in action the user has watched, and number of movies in say comedy the user has watched, and then number of movies in let us say sci-fi or maybe some what political, or let's put it like this, drama, right? If every profile contains these three qualities, rated, or the number of movies that they have watched based on their history, if this is the profile that, say for example, Netflix uses, in that situation, what will be the user A's profile? If I have to imagine a number, let's imagine a number np dot array. Sorry. Let's make it like the user A has watched, mm, say, 5 action movies, and then comedy they have watched about, say, 4, and then drama they don't, he doesn't like it, so he watched only 1. Okay, then let's, if we want, we can take another user B. We don't, let's take a different kind of profile for this. Okay, for this, the user B likes, let's say, comedy and drama, and he doesn't like action. Let's make it something like 1 comma 4 or 3 comedy movies, and then maybe 7 dramas. Okay, let's take 2 movies for example, to just to calculate which movies which user may prefer. Or let's take only 1 movie. Let's take, how many of you have watched, can anybody suggest a movie name which is, say, action centric, action and comedy centric? One is typing. Yeah, Manoj. Waiting. Any movie name that is more, that has comedy and action, not necessarily the drama component. I think is fine. Just give me. Let's assume a number for the movie, and then we can continue with the concepts. Shall I take something? How many of you have watched Deadpool from Marvel? Yeah, Avesham. Avesham is, let's say, okay, it's a complicated movie to be honest with you, because it contains all the components. Let's take this one. Spider-Man. Everyone knows it, right? Spider-Man np dot array. More action. So let's rate it as 5 for action. Comedy is there in Spider-Man to great extent. So let's say, for example, or out of 10, I will rate it 10. Action is there, and then some comedy is there, so let's make it 7. Drama, not that much, so let's make it 1 or 2. Okay, now we need to find out which user is more likely to like Spider-Man. Okay, so like I said in the previous class, dot product gives you the similarity between the two vectors, right? It tells you how much of vector A is influencing or is inside the vector B. That is what we had discussed. So to find out that, let me do this operation. User A at, I'm trying to find out the dot product. User A dot Spider-Man. So we got 80 as the score, the dot product. What about user B? 45. Does it make sense? So when I created this profile, I said the person has watched 5 of the action movies, 4 comedy movies, and 1 drama. Okay. User B has watched only 1 action movie, so he doesn't like action movies that much, and 3 comedy movies. Moderately, he likes comedy movies, and 7 of the drama genre. That means what? He likes more of the drama component in the movies. So that kind of movies he likes. But the Spider-Man movie has these features. They have been defined by the Netflix or whoever it is, right? It is more of action, little to great extent of comedy, but very little drama. Correct. If you look at this, or if you already have this perspective, then you can simply say, okay, user A will like it, user B will may not like it. But doesn't mean, or is it going to does the computer understand how to do that? No, right? How does it understand? It calculates the dot product. Is it clear? Let's let me do one more thing. 10, 7, right? Yeah, fine, no issues. Make sense? Just tell me whether you were able to comprehend what I was trying to tell you. So we can do something like this. Let me make the code a little proper. Score A, score with A, right? Score A is equal to user A at Spider-Man, then B is equal to user B at Spider-Man if A is greater than and what user A is more likely to like Spider-Man else print what user B is more likely. However, there is one more chance, right? That is why I used elif else print both user A and user B are likely to like Spider-Man. So if I run this, what do you expect? What do you expect? User A is more likely to like Spider-Man, right? However, if I say, for example, make this part, say user A liked only comedy movies more, he didn't even watch one single action movie, then because with the profiles that are there, user A hasn't even watched one single action movie, for comedy movies, but user B has a better score now. Make sense? Yes or no? Okay. Let's move on to the last concept. And I think there are only two left. One is matrix multiplication and another is transpose, right? If you have any doubt, you can ask away. By that time, I will create a matrix. Let us take something like this. We had taken an example in the last class, right? Was it? I had a matrix. Yeah. So for this matrix, I had taken column 1, column 2, column 3 as what? They were scored out of aptitude, then communication, and then coding. Or we can take the same example as well. There is no issue. Say, for example, in this particular program, I have done it explicitly, right? I have calculated this explicitly. Now I can actually do this in a single calculation. How do I do that? That is what matrix multiplication is. How do I do that? So users is equal to what? P dot array. Inside this one is what? User A, correct? And then user B. Let us see how it looks like. Users type and type array. Okay, let's take this. I think I have to put it inside this. Then yeah, got it right. Cool. So user one, user two. What are the features? Action movie count, comedy movie count, and then drama movie count, right? Then we have movies. What is the movie? Spider-Man. Let's take it. We already have it, right? This is the movie. Now, if I want to find out the score, what is the way? Users, the same operator we use for matrix multiplication as well. Users at and then Spider-Man. The only difference that we need to do is we need to transpose it. If I run this like this, okay, fine, no issues. See, I got the results. The first one is for user A, second one is for user B. User B is more likely to like Spider-Man. This is what we are getting from here as well. What is happening here? Instead of calculating separately, right, I'm batch processing it. If I had another user, then I could have done that too, right? Something like if there was another user, let's say, who had watched what, 8 action movies, then only no this one, what is it? Comedy movie, and then not even drama. He's a hardcore action movie enthusiast. Then what would have been his score? Let's see. See, this actually makes more sense, right? What, how does it, what does it tell you? Because look at the movie score, the highest is 10. Comedy is not that much of a component in the movie rating, and then drama is anyway very low. Now, for any action enthusiast, the movie should be attractive, right? They should like it. That is what it is giving you. Even though it looks like these two are zeros, maybe the user C will not like it, uh, and yet this gives you the proper analysis dot product. That is why we should never draw normal inferences. Instead, we should always use the dot product. Okay. Cool. What was the last operation that we had done in the last class? Was the transpose. So we have users array. Let me take the same array. How does it look like this? 0, 4, 1, 1, 3, 7, 8, 0, 0. Now with this array, the idea is what? The columns are action movie counts, and the next column is what? The comedy movie count. And the last column is drama count, right? But the rows are user A, user B, user C. Now, if I want to change the perspective, as I mentioned in the last class, all you have to do is to users dot, this will give you the transpose of this particular matrix. 0, 1, 8. These are the counts for user A, user B, user C in action movies. So the rows have become the vectors here. The previous features have become the vectors here. So the first row is now the action movie rating. Second row is what? The comedy movie rating. The third row is the drama movie rating. And the columns have become user A, user B, user C. We are simply changing the perspective. Fine. This is how you do this. It is just about how to do that as an operation in Python. Okay. The usage and um, uh, the actual use case we will come to know when we use uh, when we move into the next concepts, stats, even linear regression models, how to build that, the principal component analysis thing, all these things we will we make use of these things. So I hope you were able to follow it along. Just tell me if you have managed to get all these outputs. If you have any doubt, you can ask that as well. So if you guys are clear with this, we will wind up the linear algebra part because only this much is necessary for us for the remaining concepts. From tomorrow, I will start with the statistics. And one more thing, please comment back in the group uh, how the class is going. If you if you find something needs to be updated or the explanation needs to be more, or is there any communication gap, or should I take a little more time or find a better way to explain concepts, please let me know in the WhatsApp group. If you don't mention anything, I will have to assume that, okay, maybe I'm doing a good job, which may not be true. Okay. So please comment back. Don't think, okay, telling these things will put you in bad angles with me. It doesn't. Actually helps you many ways. All right, then if you don't have any doubts, I will terminate the class. We'll share the recording later. Shall I end the class? So in this class, if I have to see, few students are from my college itself, Vishudarshana. Few are from JMJ. I think there was one student from Government College Sirsi. How many of you are from, how many of you are present here and are from JMJ College? Is there anyone from JMJ? Who is it? There is that. Manoj. Okay. They should be like, okay. You guys will have to tell me. My students already know me, and they actually get to meet me every day. I don't get to meet you guys, right, in person. So you guys will have to let me know if you are finding the class useful or not. Is it helping you or not? If any improvement needs to be done, you just ping me in WhatsApp personally. Also, you can text me. Okay. Please feel free. Uh, we can work together later. Cool. The actual thing, right? The actual concepts will start from tomorrow. Actually, it does. And after 2 more days, we will be working with really serious stuff. Mhm. All right. Thank you. See you tomorrow.